It's a packed house for the opening weekend for this noir series. Miss Thaye Martin is back, and in her most dynamic role as Mac the PI. It's a riveting tale of crime, love, and meningeal inflammation, which brings you to a fever pitch and culminates in a grand finale that will literally leave you in shock. Buckle up. You won't be able to turn your head.
Welcome to our Neisseria Noir series. This is the first part of 3, and in this part, we're going to discuss all of the common features of Neisseria, and then we'll go into the differences between Neisseria gonorrhea and Neisseria meningitis in their respective lessons. First things first, Neisseria species are gram-negative diplococci, represented by these red handcuffs that look like diplococci. Our star has an undeniable presence and signature style that makes her stand out from the pack. And in a way, so does Neisseria. It has some unique features that help us single it out. For one, both Neisseria meningitis and Neisseria gonorrhea can metabolize glucose, as presented here by this movie candy. But only Neisseria meningitis can metabolize both glucose and maltose. To help you remember that Neisseria is also oxidase positive, take a look at this blue onyx pendant. These blue onyx rings and necklaces are our recurring symbol for oxidase positive. Okay, here are some important growth characteristics you should know about. Neisseria are unable to grow in sheep's blood agar, and this is because they're inhibited by some of the lipids and other elements found in blood agar. But if you heat up blood agar, it turns a nice chocolate color, and it renders these inhibitors inactive, allowing both species of Neisseria to grow. This heated blood agar is known as chocolate agar, and we'll represent that here with this chocolate bar. And another important agar that you should know about is VPN, which is selective for Neisseria. VPN, which we've represented by this sign, the Vice City Private Investigator sign, is a special medium enriched with vancomycin, polymyxin, nystatin, and trimethoprim. These special ingredients inhibit the growth of other bacteria and fungi. The name for this growth medium with VPN is called Thayer-Martin agar, which also happens to be the name of our cinematic star. Miss Martin is starring as the one and only Mac, PI. We've centered our feature presentation around Mac, a crime-fighting PI, because MAC, or membrane attack complex, is an essential host defense mechanism against Neisseria infections. You may recall that MAC is a complex of proteins formed at terminal stages of the complement pathway. Do you remember what deficiency causes increased susceptibility to Neisseria species? For the answer, check out MAC's listed hours of operation. That's right, it's terminal complement deficiency, specifically of C5 to C9. So that means she's a PI by night, which I imagine are good hours to be a PI. So when patients are deficient in these complement factors, they're unable to form the membrane attack complex, or MAC. Remember, MAC leads to ultimate destruction of the bacteria by poking holes in it, which causes osmotic flux and then lysis. All right, let's move on to some of the virulence factors of Neisseria species. Neisseria's major virulence factor is its pili, hence these finger-like projections coming off of Mac's earrings. Pili allow the bacteria to attach to the mucosal surfaces, as in the pharynx. But bad news for our immune system. These pili undergo frequent antigenic variation, which makes it difficult to neutralize the infection. Another important virulence factor is the production of IgA protease. This special protease makes it much easier for Neisseria to evade the host immune system and colonize mucosal surfaces. So to help you remember that Neisseria makes an IgA protease, Mac's got her signature ACE card here that's torn slightly to remind you that Neisseria can inactivate IgA. Okay, finally we get to the title of our feature, which is the Lost Flame. Are you sensing a double meaning? The LOS in lost stands for lipo-oligosaccharides. It's a super inflammatory compound made by Neisseria, and it's similar to endotoxin found on other gram-negative bacterial species. It's an important virulence factor to know about because it revs up the pro-inflammatory state It makes our immune system run wild and causes a lot of destruction. In the next videos, you'll see that LOS is a big reason why folks get really sick from Neisseria bacteremia. The last virulence factor we need to cover is Neisseria's OPA, or opacity proteins, which are found on its outer surfaces. OPA proteins, represented by this opaque window, help Neisseria form tight bonds with one another and to host cells, which aids in bacterial colonization. Neisseria can even vary their expression of OPA proteins, and again, that's just another way Neisseria tries to outsmart the host's immune system. And that's it for our intro to Neisseria. Grab some popcorn and watch the story unfold in parts 2 and 3 of our Neisseria Noir series.
The lost flame is missing? You don't say. I'm on my way, just stay right there.
Welcome back to the Film Noir series. In this video, we will cover Neisseria meningitidis, the cause of meningococcal meningitis, the second most common cause of acute bacterial meningitis. By the way, Streptococcus pneumoniae holds the #1 spot. First, let's start with a quick recap. Neisseria are 1. Gram-negative diplococci, 2. Oxidase positive, 3. Glucose fermenters, 4. Growth on chocolate agar, 5. Also grow on VPN, aka Thayer-Martin agar. 6. We see increased susceptibility in C5 through C9 complement deficiency because of lack of 7. MAC complex. 8. Major virulence